circuit, like as I've been telling in all the classes, that electrical engineering is actually full of circuits. And basically, there are circuit elements, and we are gradually learning the new circuit elements. We have introduced resistor, inductor, capacitor, and how to handle complex circuits, different types of transformation. We have studied that will that will be required. Now, another vital aspect of electrical engineering is basically the switches, and a lot of switching is basically done throughout the network. In your home, you are always doing some switching. In summer, you use the fan, but you don't use the fan in the summer. Okay, you are using. There are a lot of lights in the room. You are changing the lights depending on your requirement. Okay, you are switching on different types of gadgets. So switches play a very vital role in electrical engineering. Now, the purpose of this class is, that if just we have a simple circuit of RL elements, and some switching is done, and so what happens before the switching and what happens after the switching, because L, that is the inductor, is such an element that it can store energy. So this is the this slide, though I discussed in the previous class. So this is the circuit on the top right, where there are two resistances R1, R2, and there is an inductor in parallel with R2. And the switch was, the way the switch is shown, that at t equal to 0, the switch is opened. Okay, so what happens before t equal to 0, that is at t less than 0, the source was connected to the circuit. So the left side bottom, this was the circuit for t less than 0. But at t greater than 0, since the switch was operated, so what actually happens is, this is the circuit. So the source is basically disconnected from the circuit. Now, so if a source is disconnected from the circuit, so in that circuit there will be no electrical quantity flowing, present. But in this case, we have an inductor. Okay, so this inductor we have studied is an element that can store energy. So even if the switch is opened, due to the inductor, energy that has been stored, there will be some amount of current in that circuit, and it will, though an inductor, basically the inductor will be acting like a source, but an inductor is not a source like a battery. So it has finite amount of energy, and until unless that energy is dissipated, it will there will be some electrical quantity in that circuit which will eventually die out. So this was the these are the situations when for t less than 0, t greater than 0. Now what we are actually interested is in this, that when there is just the inductor in the circuit, and how the electrical quantities change. Okay, so we discussed about this in the previous class, and so it basically boils down to solving a differential equation, and of this form, that Ri plus VL equal to 0. Okay, and we know that it is a differential equation, first order differential equation, and we solve it. Okay, first order you can solve it by many methods, and what is actually required is, the time is starting at some instant I at 0, and at what happens at a particular time t in that circuit. So if at the time 0, if there was some initial current I naught, okay, so this will basically be the limits of the integration. So ultimately we get the value of current in this form, it equal to I naught e to the power minus r by lt. And so there are more general approaches. In fact, this approach we did in the previous class, and we saw that if for this differential equation this is the solution, since I is a function of t, so explicitly I'm not writing the t as I told you, because but this small index basically means they are function of t. So if we assume the solution it equal to a e to the power st, and substituting this here, we ultimately get this type of equation, and ultimately the objective is to find out an a and s that satisfies this equation. So we saw that this equation s plus r by l a e to the power st equal to 0. So the left side, mathematically, what will be there in the left side? So the variables are s and a. such that it becomes 0. So we saw there are different options. So if you put S equal to minus R by L, the left side becomes 0. If you put A equal to 0, the left side becomes 0. And if you put S equal to minus infinity. So these were the possible options that will make this 0. Now we also saw that out of these all these options, all of them are not feasible options because some of them are basically lead to trivial solutions. Okay, say IT equal to 0. So just considering 0 as a solution is meaningless because we are handling a real circuit. And we saw that these are the two trivial solutions. That is S equal to minus infinity, A equal to 0. So whatever left with, that is S equal to minus RT is the minus R by L is the acceptable solution. So ultimately we get this IT equal to A e to the power minus R by LT, and putting the condition at t equal to 0, we get I is equal to I naught. So your A becomes I naught and IT equal to I naught e to the power minus t by L by R. So this L by R we are substituting by a new variable, by a new term called tau, and so your expression becomes IT by I naught. Okay, IT by I naught equal to e to the power minus t by tau. So if we plot this IT by I naught, if we plot this, we did this in the previous class. So at t equal to 0, the value is basically 1, and this is having a characteristics which is exponentially reducing. So that is IT by I naught. And we also did some other thing, like if we differentiate IT by I naught with respect to t, obviously because I is a function of t, and then you substitute a t naught. So what we are basically doing is we are trying to find out the slope of these characteristics IT by I naught at t equal to 0. So we found that this is equal to minus 1 by tau equal to minus R by L. If you substitute that tau, we found in the previous, we substituted earlier. So this is the basically the tangent. So this tangent cuts the time axis at a particular time t. So what is of interest is what is this time? Why is this time important? So it basically means that if that IT by I naught decays at the rate at which it is at t equal to 0, at what time it will become equal to 0. Some of you please mute your mic, there is some background noise. So if IT by I naught reduces at the rate that is at t equal to t naught, then what is of interest is what is this time at which it will this current will actually degenerate to 0, decreasing at the rate at t equal to 0. So this is basically equal to if this tan theta, the slope of the line is r by l, the magnitude. So it is, so this side the magnitude is basically 1, okay, along the y-axis, and here this magnitude is t. So we are trying to find out what is this t. So this t is basically equal to r by l by r, which is equal to the tau that we assumed earlier. So this tau is basically called the time constant of the circuit, L and R. So when you have an LR circuit, L by R basically gives the time constant of that circuit, and it is basically having the units of time. So time constant is the time taken for I by I naught to drop to unity, from unity to 0, assuming a constant rate of decay as the decay rate at t equal to 0. So that is basically the definition of time constant. This is a very popular question asked during the interviews, interviews during the lab vivas and all, when you will be doing the uh, electrical technology lab. Okay. So this time though you will be doing the virtual lab, but there are many places you will have to handle this type of LR circuits. And this is a very popular question. What is the definition of time constant? In many books, you will find it written in different forms. But the purpose of this showing is it is basically the time taken for I by I naught to drop from unity to zero, assuming a constant rate of decay, assuming this initial rate. So that is the time constant. Okay, so in many books you will find many other definitions. So suppose this IT by I naught, given the expression, if you put t equal to tau, the value becomes e to the power minus 1, which is 0.367. So in some books you will also find this definition. That is the time taken to reach 36.737% of the value. But that is not the actual definition. So it is just a value. So if you put t equal to 2 tau, you will get some other value. If you put t equal to 3 tau, you will get some other value. So though in some books the definition is written in this form, but when you are asked about time constant, you what is basically expected if you give the definition of this form, that is time constant is the time taken for I by I naught to drop from unity to zero, assuming a constant rate of decay as the decay rate at t equal to zero. So these are some of the things we did in the previous class, and we started with this on a numerical. So this was the numerical that for the circuit, find the voltage V at t equal to 200 milliseconds. So the question is, what is the value of V? And as you see in the figure, the V is basically the voltage across the 40 ohm resistance, and its polarity is shown. Now what actually happens in this circuit, you find that there are three legs. In the first leg, you have the 40 ohm resistance. In the second leg, you have the 224 volt battery along with the switch. And you see some certain directions of the switch. Okay, so the way the switch is shown, it means what? That at t equal to 0, the switch is operated. Okay, so at t equal to 0, if you operate the switch this way it's shown, it basically means it will create a discontinuity of the 24 volts battery. That means before t equal to 0, the 24 volt battery was connected, and at t equal to 0, it is removed. Okay, so there are two situations. One is t less than 0, one is t greater than 0. So basically there will be two circuits. So for t less than 0, this is the circuit. This is the situation for t less than 0 because the switch is closed. The 24 volt battery is connected to the circuit. So what will happen? The 24 volt battery will drive some current through the 40 ohm resistance. It will also drive some current across the 10 ohm and 5 Henry. But what will happen in the inductor? The inductor, what will be the voltage?
0, sir.
0, sir.
Yeah, because inductor is shorted for DC.
0, sir.
Okay, so there will be you can find out the current. Now, so IL0. Okay, so the IL0, that means the at t equal to 0, the inductor current is nothing but 24 volts by 10 ohms, so which is 2.4 ampere. And if you consider V at t less than 0, see V is the way it has been defined, V is the voltage across the 40 ohm resistance. So at t less than 0, that is before the switch is applied, this whole 24 volts is getting applied across the 40 ohm resistance. Okay, so the V at t less than 0 is basically 24 volts. You see the question asked is what is the V at t equal to 200 milliseconds? That means when the switch has been operated. When the switch has been operated, but this is the situation where before the switch is operated. Okay, so the IL0, that is an initial current. There is some current in the 10 ohm 5 Henry leg. Okay, which is only due to the resistance because for a DC inductor is shorted. Okay, so there is inductor will have no effect if there is a DC. So the IL0 is basically 24 volts by 10 ohm equal to 2.4 amperes. But the other situation is when the switch is operated, that is t greater than 0, and now as the switch is operated, so we basically have a different circuit now. Okay, so this is the circuit when the switch is operated. Okay, so the 40 ohm, there is the 40 ohm, there is the 40 ohm resistance, the 10 ohm resistance, and the 5 Henry inductance in the circuit. The battery is totally removed because as soon as you apply the switch, it has no role, because it is disconnected. Now, in this circuit, there was earlier current IL. Okay, so what will be the current? So there will be some current now in the circuit because there is an inductor in the circuit which has the capability to store the energy. Okay, so there will be some current in this way. So if there is the current in this way, okay, so how to get this current? So to get this current, you will basically apply some sort of this KVL. So you see, if you go by this way, you have V, that is the potential rise, minus 10 IL minus 5 DL dt equal to 0. So since you have this, and then the job is to solve this differential equation. So for solving this
Excuse me,
differential,
sir.
yeah.
Sir, why did you remove the 24-volt battery there to apply Thevenin's theorem?
No, you observe the circuit, the problem given. The switch is operated at t equal to 0. Okay, so the left
Yes,
hand
sir.
side circuit is for t less than 0. So the switch was there till t equal to 0. And for t greater than 0, the right hand side circuit is for t greater than 0. The switch has been applied.
Okay,
So
sir.
what happens? There is a discontinuity. So if there is a
Yes, sir, sir.
discontinuity, everything is gone from this leg.
Yes, sir, sir.
Okay. So this IL, so the IL that will be flowing in the circuit is basically equal to minus V by 40. So you see the notation, IL is coming out of the resistance. It is having the opposite polarity. So this IL is equal to minus V by 40. So if you substitute this here, you basically get this type of equation. If you substitute here in this differential equation, you have 5 by 40 dV dt. Okay, 5 by 40 dV dt. So this part dl dt, if you put IL, you get 5 by 40 dV dt, and then you are basically having this V, and you have basically minus 10, and this two minus will become plus, so it becomes 10 by 40 V. So it is 10 by 40 V plus 10 by 40 plus 1 together multiplied by V equal to 0. Okay, so this equation once simplified, you basically get this dV dt equal to 10V equal to 0. And you know how to solve this equation. So the solution of this equation is equal to V equal to A to the power minus 10t. We just saw, we have done that derivation. V equal to A to the power minus 10t. So what is the unknown here? We'll have to basically find out the unknown
Yes, sir.
for A.
A.
So given the some condition.
T is
Okay,
equal to 0.24 volt.
T equal to 0.
So 24
Yes,
so
volt
V
at
zero,
T
V
equal to
zero,
Initial condition.
so V 0 plus, that is exactly at the instant of switching. Okay, exactly at the instant of switching, what is the value of the V? Exactly at the instant of switching, the value of
minus
V is
96 volts.
minus 96
Minus
volts.
96.
Minus
Minus
96.
96 volts.
96.
So putting this into the equation, you get V equal to minus 96 e to the power minus 10t. Okay, V equal to e to the power minus 96 e to the power minus 10t. Okay, this clear? So the question was
Sir,
find the
I did not
voltage.
understand how minus 96 comes in.
Yes. See, you see the polarity of V. On this left circuit, you see the polarity of V. It is assumed positive at the top. Okay, so it is plus 24 volts. But you see in the right circuit, keeping the same though we keep the same polarity, but the current is going in the opposite direction. Okay, so it is basically minus 96 volts. The current is basically in the opposite direction because we are choosing the top terminal as the plus and the bottom terminal as the minus. Okay. So we basically get the voltage expression like this, that for t less than 0 it equal to 24 volts. This we directly got from here. For t less than 0 it was 24 volts, but for t greater than 0, that is the analysis that is being done on the right hand side, it is minus 96 minus 10 e to the power minus 10 by t. That means what happens if you plot this? Okay, say when t is negative it is 24 volts, though I have not shown the plot, and at t equal to 0 exactly it changes the polarity, it goes to the negative side, and then gradually it reduces, exponentially reduces to 0, because e to the power minus 10t, so it is, as t increases the exponential value reduces, so it becomes 0. You can plot it. Now the question is, what is the value of t at 200 millisecond? So which one will you apply? Which condition?
T greater than 0.
T greater than 0. Yeah. So if you substitute here 200 millisecond, that means you have to first convert to second. 200 into 10 to the power minus 3 seconds. So you substitute this here, you get the value of the voltage. So that 0.2 means basically 0.2 seconds. The 200 milliseconds is 0.2 seconds. If you substitute this, you will get this. This is the voltage. So that is the question. So the purpose
Sir, I
of
didn't. If sign
Ah.
came.
Huh?
Sir, I didn't got when the negative sign came. Why?
Can anybody explain?
Sir, because the current is in
Polarity
opposite.
is opposite.
Current is
See
in
this
opposite
current
Current is in opposite
direction.
direction.
See how the
Current
current
flows
is
from
going.
higher potential to lower potential.
This is the IL. Okay, so
In resistance, current flow from
IL is going from lower potential
IL.
to higher potential, sir.
IL is going from lower potential to higher potential. So the relation between V and IL is with a negative sign.
Yes, sir.
Sir, but when we have seen the V in the in the diagram, V has a plus on the top. Then shouldn't we report the answer according to the symbols given as per V?
So we are doing that only, no? We are doing that
Uh,
only. We are doing that only because the V is given and the direction of the IL is also given unknown.
Excuse
You
me,
are not free to choose the terminal voltages of the 40 ohm resistance. The terminal the ends, the positive and negative side is given. So that is how
sir,
V is defined. Yeah.
before T is less than 0, the in the left hand circuit the current was anti-clockwise.
Which one?
Sir, before T T less than 0, the left hand side's loop had current in anti-clock direction.
Yes.
Sir, and after T greater than 0, it has current in clockwise direction.
Yes. It reverses.
Sir, it reverses, but the voltage sign is means if we draw terminals the resistor always tries to oppose the current, and if we get minus current, it means sir, I think that the terminal at the top should be positive as it is in the symbol, so we should be 12.99.
So that we are getting, nah? But with a minus sign, because it is if you assume this initial convention with positive at the top, in the with positive at the top, but in the second circuit it actually happens the other way. So it is the other way has to be indicated with the negative sign, because the current reverses in the 40 ohm resistance for the two cases.
Okay, sir.
Excuse me,
Yeah.
sir. I really didn't get how that minus 96 came. Can you please explain it once again?
Again, who can explain? Somebody can
Sir,
explain.
sir, what initially the voltage was actually being measured from
from top to bottom, but right now the current suddenly changed the direction as soon as the switching was done. So it so now it is going from going in the opposite direction from which V was measured. So it's negative.
So this IL0, somebody asked minus 96. IL0, that is at t equal to 0, the IL was 2.4 ampere.
Yes,
Okay,
sir.
so at t equal to 0, that 2.4 ampere starts to go in this direction. Okay, the 2.4 ampere starts to flow. So 2.4 into 40 ohm is how much?
2.4 into 96, sir.
96. So that 96, but since now it is going in the other direction, it is minus 96. Because the
Sir, but that
polarity.
is not constant now, sir.
Huh?
That IL remains constant, sir.
IL, why will it remain constant? You have removed the
Sir,
battery.
yes,
So
sir.
that is for t greater than 0. So that is the starting point. It starts from 2.4 ampere, but so across this 40 ohm, it is in the
just
opposite
after
direction.
the time t is equal to 0. So for
Just after time t is equal to 0, it is equal.
yes, sir.
Yeah.
For just instant of 0.
At that instant. So I've given that 0 plus. Okay. So you must be knowing, you know better what is the meaning of 0 plus, 0 minus and all. Okay. So
हेलो
Yes,
सर
Clear, sir.
just at the instant of switching, yes.
सर
Yes,
हम
yes, yes.
मुझे एक डाउट है सर, जब हम लोग इंडक्टर को चार्ज कर रहे थे सर t लेस देन 0 के लिए, तो सर जो इंडक्टर का जो पॉजिटिव पोटेंशियल साइड जो होगा वो 10 ओम रेजिस्टेंस के साइड में होगा,
नहीं,
10 ओम रेजिस्टेंस है।
t less than 0 में हम इंडक्टर को नहीं चार्ज कर रहे थे because इंडक्टर was shorted. Okay, the inductor was shorted because there was a DC.
Yes, sir.
DC connected. Okay.
No voltage across the conductor.
Yes.
Inductor.
सर लेस देन 0 के लिए सर कभी तो चार्ज हुआ होगा ना इंडक्टर सर, तब ना फिर से उससे करंट निकाला, मतलब वो एक सोर्स की तरह बाद में काम किया।
that happened at that instant of t equal to 0. The change happened, you know.
Sir, at that time, sir, the positive potential across the inductor will be towards the 10 ohm resistance, na. So, sir, when we disconnect the sir battery, then positive potential will act. Then inductor will act like a source, and the positive potential will be towards the 10 ohm resistance. This means that the current drawn from the inductor will be across the will move anti-clockwise direction, na, sir.
No, the current, you know, in whatever direction it flows, the answer has to be given with respect to the direction given. We have given a direction of IL. We have given a direction for V. You see the polarities are given. So the answer has to be given with respect to that direction.
Sir, I want to know that when current is drawn from the inductor after disconnecting the battery, the direction of the current in the circuit will be as same as that before disconnecting the battery, or it will be reversed.
I think
this current IL was there. Okay, so this is the IL for t less than 0, and then the IL is also given with respect to the same direction. Okay, the expected IL has to be given. Similarly, for the voltage, we have defined the polarity of the voltage across the 40 ohm resistance. Okay, so and in that with respect to that reference, the answer is expected. If I did not give this if I did not give this plus minus sign, or if I did not give that IL, then anybody can do any assumption and give an answer. Okay, so but you have been given a specific polarity across the 40 ohm. There is a specific direction of IL, and with respect to that, the answer, once we seek the answer, you know, that will be a very unique answer. Otherwise, if you choose a different polarity, if you choose different direction of current, the answer, you know, that the signs will change.
Sir, he is saying that direction of IL should be changed because positive sign towards the 10 ohm resistor.
No, direction of IL is given this way because the inductor, the current will continue in that direction and gradually decay.
Yes, sir. It will take some time to change the direction.
Yes.
Yes, sir.
So in the books, today after the class, I will give you the list of books. This type of problems, you will have lot of numericals are possible. But what the most important thing in this type of numerical, already I have told the book of Heth and Kemerle, but some more books I will refer, is the interpretation of the switch. Okay, so in some problem the switch may be other way also. So you'll have to basically draw the correct circuit and then do the analysis. So similarly, there can be a problem, a similar problem with the same type of circuit, but some values are changed here. 6 ohm, 4 ohm, the value resistance values, the battery is 10 volts, and the switch convention is also the same. And it is asked to find out what is the value of the voltage V in the circuit. Okay, the value of the voltage V in the circuit. Okay, so you should take this as a homework, or if you can somehow do it quickly also. Okay, I will not solve all problems in the class because many of the problems will have to be solved during the tutorial. Okay, so here you will actually find out that this is the V minus 25 e to the power minus 2t. Okay, you note down the answer and you solve on your own by the different for t less than 0 one type of circuit, t greater than 0, and then choosing the polarity the way it has been shown. So the answer is expected with the polarity direction shown, the polarity of the voltage that is shown, and with the direction of the current also shown.
Sir,
So
this minus sign represents that after time t, the polarity will be reversed. Means
yes,
in place of plus, this will be minus.
Yeah, so you solve it. I don't have the solution here.
And sir, if by any chance we miss the polarity in exam, means how many marks will be cut?
That has to be depending upon the situation. How? Because once we give the polarity, once we give some direction, we want it in that form. And obviously, if your magnitude is correct, you will get some credit, some marks will be deducted. So it depends upon how much mark is also there in that question. Okay?
Yes, sir. Got the answer.
Got the answer? Good.
Yes, sir.
Okay. So these are simple. Simple. Yeah. So some of the gradually, but the more you practice, you will be used to this type of questions. Okay. So the next element is basically the source-free RC circuits. That if such a circuit is there, where there is a switching and there is a capacitor in the circuit. Okay, there is a capacitor in the circuit and there is a switching. Then basically, and obviously, once the capacitor is given, what will also be given is the capacitor as the what is the initial voltage across the terminals of the capacitor, and then what is that? So for this circuit, you will have to basically solve this type of differential equation. Okay, C dV dt, which is equivalent to the current plus V by R. And you know how to solve this. Just similar to the other. If you multiply this equation by like say 1 by C, you get V dV dt plus V by RC equal to 0. And then its solution is from it is just like the earlier case, where Vt equal to V naught e to the power minus T by RC equal to V naught, this RC, which has actually the unit of time. If you substitute by some tau, so RC in the case of an RC circuit, tau, which is equal to RC, is called the time constant of the circuit. Just like the earlier case, for an RC circuit, the time constant is the product of R and C. If there is only one R and one C, it is the product of R and C. If there is one C and some other combination of R's, basically you have to find out the equivalent resistance, and R eq into C will give the time constant. So here again, if you plot Vt by V naught, the same type of approach, if you plot Vt by V naught, it will basically keep on reducing. Okay, so the Vt by V naught will reducing, and obviously it will reduce from what? I have not shown the some mistake happened. Okay, what is the magnitude at t equal to 0?
1.
Of Vt by V naught, it is basically 1.
Yes,
Okay,
sir.
so that is how the time constant. So if at that instant, if the tangent is drawn, the point at which it will cut the time axis is basically the time constant, which is equal to the RC. So that is how the time constant is defined. Okay, this is a very favorite question in the interviews and vivas. Okay, what is time constant? And many students actually give different types of answers, and many books actually give the wrong definition. Okay, so by definition, it actually means that at t equal to 0, if to this Vt by V naught, or in the earlier case It by I naught, if you draw the tangent, so any tangent drawn at t equal to 0, the point at which it will cut the time axis, that amount of time is called the time constant. So physically, it basically means if the decay rate at initial time is followed, at what time it will become equal to 0. So that is how time constant is defined. But in many books, you will find that time taken to reach 36.7% of the value and all those things are there, which is not a correct definition.
Sir, what is the physical significance of time constant?
I have been telling repeatedly, physical significance means that t equal to 0 if it is decreasing at a certain rate. If I follow that same rate, at what time it will become 0? Okay, because since this is exponentially reducing at every point, there are different rates. At every point, you can draw a tangent. Okay, you all are experts in drawing tangents. You've done in your school. So you at every point there are tangents. But what we are concerned is what is the tangent? That means at what rate it is reducing at t equal to 0, and if that rate is followed, when it will become 0. Is it clear? Is it clear the
Yes, sir.
physical significance
Yes,
of
sir.
tangent?
Yes, sir.
Yeah. So similarly, there can be problems for a capacitor circuit. Find the voltage V at t equal to 200 microsecond. So solve this problem. So you see the switching, so t equal to 0, the switch is operated. That means the battery is taken out of the circuit. So for t less than 0, the battery was there. Okay, so at t less than 0, what was V?
9 volts, sir.
9 volt.
9 volt. That is
9
9
volt.
volt. 9 volt is applied across the battery. So that is basically your V naught. V0. Okay. Now, as soon as you remove the battery, what is the time constant? The equivalent resistance is
6 ohms.
80
6 ohms. So RC you can find out.
60 microseconds.
80,
So
80
your
microseconds.
equation is Vt equal
Six
to 9
micro-
e to the power minus t by tau V.
microseconds.
Okay, because your V naught is basically 9 volts. The entire battery voltage is there across the capacitor for t less than 0. Now you are asked to find out the voltage at t equal to 200 microseconds. What you have to do? You have to just substitute t equal to 200, but you have to be very careful about the units and times and all. Okay, so here it is asked t equal to 200 microsecond. Tau is also equal to 60 into 60 microsecond. So find the value. So V 200 microsecond is equal to 320 millivolts. You just check whether this value is correct or not. All of you sit with a calculator.
Sir, I got 321.
321.
Yes, sir.
Yes, sir.
Because
sir.
of some substitution, or maybe my answer is wrong. Okay, maybe that one is correct also. So that may happen because of some approximation or something like that. Okay, because I was doing TES 200 by 60, so I was doing that 3.33. Yes, I was doing it to the power minus 3.33, but if you do the actual value, it may be 1 millivolt later. So you can have similar problems. Another circuit. So the important thing with this type of problems is to interpret the switching. So what does this switch means? This switch
Sir,
means
it
what?
went from A to B.
It is moved from A.
Yeah. So at
A to
t
B.
equal to
Two-way
0,
switch.
it is moved from A to B. Okay. So that means for t less than 0, it was connected to A. So you know what type of circuit will it be? When that t less than 0, it is connected to A, what is the circuit will it be? So what will be V naught? Because your question is find V0.
50 volts.
50 because for t
volts.
less than 0, so something you can do orally. Vt less than 0, the whole 50 volts get applied across the capacitor. Okay, so it is 50 volts. Now at t equal to 0, there is a switchover, there is a changeover. There is a lot of changeovers, in electrical circuits. This is just a simple example, but lot of changeovers, in electrical circuit. And so switches are very important. As I told you, say in IIT Kharagpur, is basically supplied from two sources. Okay, because it is a huge campus, there are close to 25 hostels, and then there are other buildings and all, the markets and auditoriums. All of you must have been, seen these at least in the picture, this in your orientation programs and all. Okay, so you all must be waiting to visit the campus. So IIT does not rely on only one source. It has two sources, two big sources. One is the West Bengal State Electricity Board, and the other is the Damodar Valley Corporation. Okay, so it is supplied from two sources. So switches are very common in electrical circuits. So the purpose of two sources is if there is one problem in one source, at least the whole campus can be provided power from the other source to keep redundant. Okay, so this is a simple case where the switching is done. The switch is moved from A to B at t equal to 0. And then find out what is V2 milliseconds.
So 26.763 volts.
Huh?
Sir,
Yes,
14.325
14.325
volts. 14.325 to
14.325.
What is the time constant?
14.325 volts.
The time constant is 800
1600 microseconds.
800, that is 1600 into 10 to the power minus 6.
minus
1600 into 10 to the power minus 6. Okay, so then you can find out. So your V naught is equal to 50 volts. Your time constant is 1600 into 10 to the power minus 6 seconds. Okay, obviously by this R, what I mean is this 800. Okay, because when t greater than 0, this is the circuit. I have not drawn the two circuits. So it is better to make it, to make the situation clear before you.
Yeah, Kaka.
So your Vt is basically 50 e to the power minus t by tau volts. And you have been asked what is the value of V at 2 milliseconds. Now you have to be careful. 2 milliseconds, the time is 2 milliseconds. 2 milliseconds means 2 into 10 to the power minus 3. And here this is tau is 1600 10 to the power minus 6. So you have to be very careful. And ultimately it comes to 14.327. So all of you got this?
Yes, sir.
Yes, sir.
Okay.
So it's actually 3 to 5.
Okay, so that
Yes, sir,
small amount of difference may take place.
Yes, sir. Yes.
So what will
Okay.
be the tolerance limit for the electrical answers?
What is the name? It is very difficult to tell. Okay, so those if the
Tanmay
first two,
Datta.
Tanmay Datta. So if the first two places of decimals are correct, that means more or less it is correct. But third place will not matter much.
So I mean,
Until-
sir, in the assignments or the tests, what is the accepted limit of error that we can do? I mean, in the decimals.
No, you should be trying to give the accurate value.
Yes,
Okay,
sir,
and
but there is some calculation. I mean, some calculation error might creep in. So
So
that
what
we
is
will
the
see.
actual?
That will be, you know, that will we will understand, you know, from your answer whether it is
Okay, sir.
correct or not. With little bit of change, we give the full credit.
Okay, sir. Okay, fine.
Okay. Now, a more general perspective means, suppose you have a circuit like this, a combination of resistances and inductances, and there this type of switching is taking place. So here, basically, the equivalent resistance is nothing but, you know how to do this. R3 plus R4, because they are in series in parallel with R1, R2, and tau is basically equal to L by Req. If there is a problem where there is the this type of circuit is there, then you have to basically find out the equivalent resistance and then combine it with the L to find out the time constant and then go ahead. Now, the distinction
There are
between
two
zero,
inductors.
the two inductors we have already
There are
taught.
two inductors.
We have taught earlier how to combine inductors also. If they can be combined, they have to be combined. You know. We have learned how to combine the inductance. Similarly for capacitance also. Now there is a clear-cut distinction between 0 plus and 0 minus. Okay, this thing you already know. What is the meaning of 0 plus? 0 plus means proceeding towards zero
Just
from the
after
right hand side. Proceeding towards zero from the right hand side. Okay, and 0 minus means proceeding towards zero from the left hand side. So your IL equal to IL naught e to the power minus t by tau. Okay, so this I2, suppose you are asked to find out I2 at t greater than 0. So you can find out. So I2 is basically the current division, but with a negative sign. That IL with a negative sign, because I see IL and I2 are in the opposite direction. So to get I2, what you have to do? You have to do R1 by R1 plus R2. Then IL naught e to the power minus t by tau, but with a negative sign. Okay, with a negative sign. It is clear?
Yes, sir.
Yes, sir.
So similarly, so we know this, that if you are asked to find out what is I1, I1 t or I1 0 plus, is basically the limit of that from the right hand side as t approaches 0. So around 0, you basically have two sides. One is if you are coming from the right hand side towards 0, or if you are coming from the left hand side towards 0. So if you are given the initial value of I1 as I1 0 plus, then you can find out the initial value of I2. How will you find out? So it is basically this. The potential across both of them are the same. Okay, I1 0 plus into R1 is equal to I2 0 plus into R2. So just by this I2 0 plus is I1 0 plus by into R1 by R2. Similarly, IL 0 plus, that means the current through L at 0 plus on the, that means as at t is greater than 0, is basically minus I1 0 plus I2 0 plus. So these are just what I have writing down is some manipulations, which is some obvious manipulations. So if you substitute this, I2, so you ultimately get this, that IL 0 plus equal to minus R1 plus R2 by R2 I1 0 plus. Just to write it in terms of writing IL 0 plus in terms of I1 0 plus, or either way, if you are asked to find out to write IL 0 plus in terms of I2 0 plus, also you can write down. So your I2 is basically, I2 is what? So this is I2. You see that I2 is minus R1 by R1 plus R2 IL 0 e to the power minus t by 2. So if you put this IL 0 here, this IL 0, this expression, if you put here, what will happen? This minus and minus will cancel. This R1 plus R2 will cancel in the numerator, and what you are left with is I1 0 plus R1 by R2 e to the power minus t by tau. So just substituting this here, this IL0.
Excuse me, sir.
Hmm.
If there is an inductor connected between R2 and R4, then in which across we have to calculate the R equivalent?
If it is connected across R2 and R4,
Yes, sir.
so then R3 and L is also present or absent?
Present, sir.
Okay, then you have, obviously the problems are given such that it is, they can be reduced in some form.
So they are also it's the same thing. No, we can use series manipulation.
Yeah,
we
you
are
can do this.
expecting-
Yeah,
Yes,
because
sir. Yes,
those,
sir.
those things, we have not yet come to those, how to add those.
So
Given in
it's the
some other
same thing
lecture.
anyway.
Similarly, if you have RC circuits consisting of a single resistor and several capacitors, your tau is equal to Req. Sorry, this will be R into Ceq, whatever it is. If there is more than one capacitor, it will be no. This will be multiple resistor and single capacitor. So if there is more than one capacitor, it will be tau equal to RCEQ. And if you have several resistors, several capacitors, okay, so the time constant of the circuit will be the R equivalent to the C equivalent. Okay, so that will be, depending upon the different types of problems that we will see in the exercises.
Excuse me, sir. I have one
Hmm.
doubt. So in JEE, sometimes there were questions in which there were two capacitors and some charges were there. Means C1, C2, and they had charges Q1, Q2. So in that cases, I didn't get how to combine those because some charges were also present. Sir, so in that, sir, we used to extract the battery out of it, but I was not very comfortable with that method. Sir, so can you take any example of combining such capacitors where some initial charges are present?
I will do it next day because right now these are not there in my slides. Okay.
Okay,
So,
sir.
or maybe we'll see if there is something in the tutorial, that type of thing. Obviously, they will be there in the book. There are a lot of such problems.
Okay, sir.
Now,
Sir, I
Yeah.
have a doubt in the previous slide that when there are several capacitors and a single, several capacitors and several resistors. So, across which two terminals do we calculate Req?
Yeah, so that is, these are some general languages I have used. It will depend upon the exact problem given. The exact problem, because what we have done is we have introduced the concept of time constant CQ into C into R. Okay, but these are some general terms I have written which will actually depend upon the type of in the side. Just like this, to explain this. Okay, given this, you can see that these can be combined in parallel, they can be in series, and so that becomes Req, and so it is L by R. So given some other problem, we have to see in how we can express the equivalent. Then only we can do it.
Okay, sir. Understood.
So
These
here
are
also
some
the tau will be L equivalent by R equivalent.
Yes, those will be there. Once there are multiple circuit elements. Now, the next thing that we have to learn is that, so long we were considering a circuit where we were putting a battery. So battery is basically the input to the circuit. Without a battery, a circuit is meaningless. You can take several elements, resistance, capacitance, inductance, connect through wires and leave it like that, it is meaningless. Okay, we have to basically apply an input. Okay, so in that case, what we have learned so far is a fixed value of the input, a fixed value of the battery voltage. Okay, when you do the experiments in the lab, basically you have to charge the circuits. You have to put energy into the circuit by connecting the sources. Now, so far what we have done is basically the DC source where the value is fixed. Okay, if you buy a battery from the shop, the voltage across the two terminals is ideally it has to be fixed, though it so that is with the sources or the supplies are basically called the inputs. So there is some so the inputs can be classified. The first one is called the step input. That means if you're for t less than 0 you don't apply anything, and for t greater than 0 you apply a certain magnitude. Okay, for general I have kept a value of 1. So it will basically look like this. Okay, so at t less than 0, the value is 0. If t greater than 0, the value is 1. It is called a step input or DC. Okay, in our case, when we will study, we have already studied the battery. It is basically the direct current, just a single battery producing current only in one direction. So this
Sir,
is how
how
it can be mathematically represented. Yeah.
Sir, how can we physically realize this? I mean, this.
Which one?
This step input. How can we physically realize this?
No. Physically realize means you by the switch. You are doing the switching at t equal to 0.
But every battery takes some time to reach its peak stable voltage, no?
Okay, but ideal case we are considering as soon as you do the switching, you are basically applying the full voltage.
Okay.
So I
So
think he's referring to the
Sir, here
L and
Hello.
Yeah. Yes.
Sir, your inputs means in what context? Like, what does the input here mean?
This is how it is mathematically represented. Okay, input means in a circuit the input is basically a source. Okay, and which is basically the battery. We have done this circuit so long that at t equal to 0 some situation is the switch is changed, the voltage is applied. So that is basically the input. Okay. So this is the mathematical representation we will see. Now there is something called delayed step input. Delayed unit. Why this word unit? This is again called unit because just magnitude I have kept as 1. It could have been some other value. It could have been kept 5. It could have been kept some constant a or something like that. So then, but it is as soon as we keep it 1, it is called a unit step. Okay. So those of you who will be, who are E or EC students, who will be, or even mechanical or even chemical, will be basically do a course on control systems. There you will find this is the mathematical representation of unit step input. So a delayed unit step input, as I seen use the word delay, that means it is signified by u t minus t naught. That means the value is 0 for t less than t naught, and for t greater than t naught the value is 1. For t less than t naught the value is 0. For t greater than t naught the value is 1, and it basically looks like this.
so basically the switching was delayed here, right?
Switching is basically, or some situation has happened, delayed means obviously t equal to 0 is some reference. With respect to that reference,
It is taking time to reach the peak value.
not time to,
Yes,
it is
sir.
not that, it is done, the switching is done at t equal to t naught.
Oh, okay, sir.
Okay, not reaching the peak value. We are assuming that to reach the peak value it takes no time actually. An ideal case. Okay, so this is the delayed step input, and this mathematical representation. Similarly, there is something called impulse function. That means if you have a input that t equal to t naught, certain switching is done, and again at t equal to t1 it is brought down to 0. Okay, so this value is this magnitude should have been v naught. Okay, this magnitude should have been v naught. So at t less than t naught the value is 0. From t naught to t1 the value is v naught. Okay, there is a mistake. This I can.
Sir, here T0 and T1 have to be very close values.
They can be closed. They can. It depends upon your application, what you are trying to do.
Okay.
So I can't see the slides.
Can you see now?
No, sir.
No, sir.
No, sir. You are not sharing us.
No, sir. No, while correcting, I actually removed that. Now can you see?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
So that
sir.
V naught was 1, so I just changed it. Okay, so now my slides are getting corrected. Okay, so this is called the impulse function. So an impulse function, you can see that an impulse function can be represented as a combination of two delayed inputs. Suppose you apply one delayed input at t equal to t naught, and then you remove that delayed, remove it, you subtract from it another delayed unit at t equal to t1. So we basically have this. You understand? So delayed input, it can be represented as a combination of two step inputs. So at t equal to t naught, the delayed input is applied, and then there is another delayed input at t equal to t1, which is actually subtracted from it. So this is just the mathematical representation. Okay, you switch on at t naught and then switch off at t1. Okay.
Sir, please, last expression, can
Sir?
you explain once again?
See, at t equal to t naught, this is the delayed input, the second figure from the top. Okay, there can be another delayed input at t equal to t1. If you subtract the second input from the first, you basically get this. At t equal to t naught, if you have a delayed input, at t equal to t1 also there is input, and if you subtract the second one from the first, that is shown in the expression below, you basically get the impulse.
Yes.
So the purpose of telling this is gradually we will be, whenever there is
the expression written below.
yeah, okay. So this is basically a combination of two delayed inputs. So one delayed input is this. See the second figure. This is u t minus t naught. That is a delayed input applied at t equal to t naught. Now there can be another delayed input applied at t equal to t1. So if you subtract the second delayed input from the first, you basically get this impulse. A delayed input at t naught, and then there is a delayed input at t1. If you subtract the second one from the first, what is left with is this. So this is shown by this
Yes, sir. Yes, sir.
expression below.
Yes, sir.
Yes, sir. Got it.
So the purpose of telling this is basically in a circuit, so long we had applied the DC source and solved the circuit. But we also saw that, that when we have R and C, there can be the time varying nature of the circuit, the current and voltages. So similarly, the source can also be time varying, and the source is basically an input. So here we are basically representing, giving the different mathematical forms of the input. The different
Sir, in the last expression, if we put t is equal to t naught, it is not reducing to 0.
Which one?
The last expression for impulse function. At t equal to t naught, it is not reducing to 0.
No, ut minus t naught. Yes.
That right last term will stay.
It is a representation. Ut minus t naught is a delayed input. Okay, at t equal to, if your value, so this is actually coming from here. You see the step input command formula, ut equal to 0 for t less than 0, for t greater than 0 the value is 1.
Yes,
greater than equal to 0. So if you put t equal to t naught, what is the value here? Greater than it is exactly 0. value is 1?
Yes, sir.
But for this, the value is what? On the right hand side, the value is negative. So this value is actually 0.
Okay, sir. Yes, sir.
The actual definition is the
Can you
definition of
explain
ut
again,
is
sir?
which one?
Sir, last equation I did not got, sir.
So it is subtracting one input from the other. This is an impulse. It starts at T0 and then again at T1 it is not there. So if you consider at T equal to T0 a step input, delayed step input, and also at T equal to T1 another delayed step input, so you subtract one from the other. So it is point-wise subtraction. So after T0 everything will be cancelled. So what is you are left with is this.
Sir, at T equal to T1, we are switching another switch.
Okay. So you have both the components will be there and they are cancelling each other. At T equal to T1, in the first expression it is T1 minus T0, which is positive.
Yes, sir.
So positive means 1, the definition of the step input. And at T and in the second part you are getting T1 minus T0, which is equal to 0. Equal to 0 is also 1. So they cancel each other. So beyond T1, they will actually cancel each other and everything is 0. So you get an impulse. Okay.
Yes, sir.
Then there are different types. So this is something called a ramp input. Ramp means which is ut is equal to kt. Just as t is increasing, it is also increasing. At t equal to 0, the value is 0. Okay, so it is having a slope of k. This is called the ramp input. That means if it is possible that there is an input, okay, in our case it will be sources. If there is a sources that keeps on increasing with time, then that type of input is called the ramp input. Similarly, there is something called sinusoidal input. ut equal to a sine omega t. So it will basically look like this. Sorry, again the value is here. This is 1, but it is actually a. So can you see now?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So this, when I have tried to draw the sinusoidal by hand, but it should be like this. You know what is sine omega t, and so it will repeat. It is having a after every t interval, it will keep on repeating. Okay, so it will be positive, it will be negative. So this is a sinusoidal input. And this way, there are different types of inputs that are possible, but these are the basic inputs we will be. In fact, all of them we will not require also. We have basically that constant battery source is basically the step input can be considered, and if you switch on and switch off a battery, you get a impulse type of signal, and there can be a delayed operation of a battery, which is the delayed step input, and we will gradually come to the other inputs, which is basically the sinusoidal input shortly. So,
excuse me, sir.
Yeah.
Sir, is the u of t function the voltage function? Okay, sir.
No, yeah, it will eventually be the voltage function, but I am just giving some mathematical form first, because ultimately we have to solve equations, and that can only be done if the mathematical form of the source is also known. So long we were doing constant sources, some 24 volt, 10 volts, all those things were there, and we could find out the we could find out the solve the circuits. But gradually we are finding that the quantities are time varying, and that will also happen because the sources are time varying. Okay, so eventually they will replace the sources. I have not told them. We are gradually coming to that.
Okay, sir.
So the next topic means gradually we will come to this is basically alternating current. That means if your voltage source is of this type, Vm sin omega t.
Sir,
You
could
know
you
how-
show the previous slide, sir? Okay, thank you, sir.
So the next source is if your voltage source is a function of time. Okay, and so it is having a sinusoidal nature. So your Vt is equal to Vm sin omega t. You know how sin omega t will look like. Okay, you have done trigonometry, so you know how if it is varying with time. Okay, where will the value be 0?
T equal to n pi by omega.
So at t equal to 0, the value will be 0. At t equal to pi, the value will be 0. At t equal to 2 pi, the value will be 0. Maximum t equal to pi by 2. Pi by 2. So
Pi by 2.
not just t, whatever is there. Omega t equal to pi by omega t equal to pi by 2. Okay, the omega t equal to pi by 2, the value will be maximum 1. Minus 1. Okay, and so on. So you know how this will look like then. So this value Vm is basically called the magnitude of the voltage source, because the next part is varying sinusoidally like a sine wave, but with a certain magnitude. If your Vm is 1, it is having a maximum value of +1, minimum value of -1. But it could be some other value also. So an alternating voltage source will have the form Vt equal to Vm sin omega t. It could also be Vm cos omega t also. Cos omega t is also sinusoidal, but with a, what is the difference between sin omega t and cos omega t?
Phase difference
Phase
pi by
difference
2.
of pi by 2.
Phase difference of pi by 2.
So cos omega t will be maximum at omega t equal to 0. Okay, it will be minimum at omega t equal to pi and so on. So you all know this. So this omega, which is associated with this sine, with this sinusoidal voltage, is unit is in radians per second, and this omega is equal to 2 pi f. Okay, so that is the frequency of the sinusoidal wave. So unit of frequency is basically hertz. So your Vt is equal to Vm sin 2 pi ft. Vt equal to Vm sin 2 pi ft, where the unit of frequency is in hertz. Okay, which is the supply frequency. All the sources that we are enjoying, most of the sources, in your home, in your IIT, in your rooms, is basically an alternating source. Okay, our battery that you use, the pencil battery you see, or some other battery, those are all DC sources. They are the current flows in one direction. But here the current direction of the current flows alternately, and it all depends upon the supply frequency. So what is the supply frequency?
50 hertz.
50 hertz.
50 hertz for India.
So
50 hertz in India.
before coming to the supply frequency, so all the energy sources that we enjoy are basically alternating sources. Okay, so alternating current, alternating voltages. But there used to be some earlier, maybe about close to 80 or 100 years ago, some of the domestic users used to get supplied from DC. Okay, so even if some of you are in Kolkata, there is still some part of Kolkata that is where the users are DC users. They use DC power. Okay, and if there is a DC consumer, the power supply company also has to provide them DC power. Okay, there are some regions in central Kolkata where still the users are DC.
Sir, which
And
part?
where is your home?
I am from Kolkata only.
So where?
Kolkata. I am from Kestopur near Baguiati.
Oh, you are very near to my home. Okay.
Oh, nice.
But it is not that side. It is actually the old Kolkata. It is actually the central part of Kolkata in the Maniktola region.
Oh, achha. I didn't know about this.
I know this because I actually worked in Calcutta Electric Supply Corporation.
Oh, okay.
So I before becoming a professor, I worked in industry for 3 years, and that was also in Calcutta Electric Supply Corporation. So there are some
So, sir,
yes.
if the DC power is supplied, then the normal TV, refrigerator won't work, right?
Yes.
Then do they buy some special TV or what?
No. In fact, I have been to some of those homes there. They have to install some other device that will be convert this DC to AC and operate them.
Okay,
Maybe in the old days there used to be DC refrigerators, but they will not be there in the market now. Okay, but once these power sources were used earlier, maybe 80, 100 years ago, if there was a refrigerator there, then at that time they used to be DC because they will be only DC power was available at that time. So as I told you, in some parts of Kolkata, it is still DC power.
Sir,
And
if
there
reasons
is
why are they sticking to any special reasons why are they still sticking to DC power?
What is your
So
name?
I guess transmission.
Sir, Chirag
like-
Ghosh.
Chirag Ghosh. No, see, Chirag. What is the department?
Sir, computer science.
Computer science. In computer science, there will be a lot of DC. Okay, but DC has certain advantages. DC has certain disadvantages also. Okay, the advantages are you will see the numerical solving them is so easy. You don't have to something constant. You just solve it. L and C are immaterial. Only resistance. You just solve some Ohm's law and you can solve the circuit. Okay, but as Chirag is asking why there is DC, because if somebody is DC, suppose you are a resident of that central Calcutta where your house was built by your grandfather and there is DC. So they are basically DC consumers. Now this power supply company cannot tell them overnight that you become an AC. Okay. So the power supply company cannot tell the customer that you start taking AC because now we'll stop DC. You understand, Chirag?
Okay, sir.
Okay, so nobody can.
Wires only.
Huh?
The power transmitted through the power lines same as the AC current.
No, it will be the DC power. Okay.
Similar poles are erected or what I'm asking.
Yes. Obviously, the power has to be transmitted through poles and cables only. Now, where power cannot go in wireless. So, no, it has to be the poles will be required.
Sir, would it be of same cost?
Same
Cost.
No, those things will change. There will be some changes. Obviously, there are other things will be different. Because the technology is different. So, can anyone of you tell? Huh?
DC would be more costly, right?
I am not going to that costing thing. It can be costly. It can be. Exactly. I don't. That has to be found out from the power supply companies. We are not
Sir,
doing that.
Sir, those Maniktola homes are surely not residential, are they?
No, they are residential. Right? They are there for maybe from the time of Babur or so on. The old that is the oldest part of Kolkata.
Yes, sir, that is I know, but
They are
Acha.
still there, but maybe they are reducing gradually. Okay, they may be big. As somebody asked about the refrigerators, and they must be changing their wiring or changing their all those things also are there. But there are, if there is some vintage home, that they may still be having AC. That DC, sorry. Now another quiz question. Okay, though it is not. Can any one of you tell another DC application? DC application.
Sir, experiments.
For electrolysis.
Sir, motors, DC motors.
No, DC motor fine. I am telling you some.
Sir, electrolysis, sir.
Electrolysis.
Those are okay. Those are all school level things. I'm just asking some very big application where they only. Huh?
Windmills.
Windmills, no.
Electric cars.
Solar cells.
So those are there, but one application is
computers. Say metros.
no, not metros.
Electroplating.
Hydropower.
No, those may be all DC applications, but some very popular application that I will leave. I have to
Particle
tell.
accelerators.
The Calcutta tram is the DC. All of you have seen the Calcutta tram?
Yes, right, sir.
You must have
Yes,
boarded
sir.
those
Yes,
of
sir.
Calcutta or you have
Yes, sir.
in a photo.
Yes, sir.
The entire Calcutta tram system is actually DC. Okay. So that is DC. So there can be other applications, computers and all, but that those are, and they are there for hundreds of years. The Calcutta tram is nowhere in India there is tram. So that is a very pollution free. Visited, eventually for coming to Kolkata, you have to visit via Calcutta. So sometimes board the tram, which is entirely DC power. So now coming to AC, so Vt is equal to Vm sin omega t, where omega equal to 2 pi f, which is the 2 pi f is the frequency, which is the supply frequency. Now this frequency value, it changes from country to country. And for most of the countries in the world, including India, the value of frequency is 50 hertz. Okay, so the value of frequency f equal to 50 hertz. Okay, there are other values of frequency f equal to 60 hertz, which is there in USA, Canada, and all. The value of frequency is 60, but India and the entire Europe is actually 50 hertz. And then there are some other frequencies, like frequencies of 400. If you board the aircraft, aircrafts also need power. Okay, if you board the aircraft, there is the requirement of power for the AC inside the aircraft, for the lighting systems, for the other things. Okay, so the entire aircraft power system runs on 400 hertz supply. Rockets, any rocket that fly to the Mars or Moon or anything, so the entire rocket will also need power. So their power system is basically operated at 400 hertz. For any military application.
Sir, what is the reason for how the power is supplied in aircrafts?
Obviously, there is a power requirement. You must have seen, the engines are started. So along with that engines, how the aircraft operate, the engines are started. Basically, they have to burn some fuel, just like your car has some fuel. Your car has some petrol or diesel. Similarly, aircraft is aircraft turbine fuel is there. So therefore, by burning the fuel, they start the. Yeah, so I'm telling that. So that fuel will run by operating a turbine, and coupled with the turbine is the generator. The same type of architecture I told for the thermal. Itself. Yeah, it has to generate itself. If an aircraft is flying from Kolkata to Delhi, it has to have its own generator. all the engines are basically having a generator coupled to it. Okay, even in your car there is a generator. Yes.
Will the difference in frequency change the mechanism or application of my appliances?
No. Change in frequency will not change, but change in frequency is there for a different technical reason. There are technical reasons behind this. So some of these I may discuss once I start the discussion on induction motors at the end. Okay. So basically what happens is as the supply frequency increases, the size of the machine comes down. Okay,
So
the size of the
frequency will change the amplitude.
Change in frequency
will change the amplitude.
No, we are not going to change the frequency, because suppose it is in India, there is the frequency, it has to be there throughout India. 50 hertz, their frequency will not change. So what actually happens is if the frequency changes, the size of the equipment comes down. So once it is an aircraft, you are flying in the air, you cannot fly with a bulky generator. Okay, because even in the air, the aircraft is flying with 200, 400 passengers, or there is an aircraft flying from, Delhi to Kolkata 2 hours, or say it flies from Delhi to, say, New York 15 hours. Okay, so it needs power throughout the 15 hours of journey carrying 400 passengers for different purposes, like air conditioning system, maybe there is some entertainment system, and then, it is carrying the food to heat that food and all. So it needs power. So when a stretch of aircraft is flying for 15 hours, if you fly from some aircraft, Air India aircraft from Delhi to New York, it will take 15 hours. It will fly over the North Pole. So for 15 hours, the power has to be there. So it cannot. It has to have the sufficient energy. So if it carries a bulky generator, it will act as the payload. Okay, so the generator size has to be brought down. So if you increase the frequency, generator size comes down, the machine size comes down. So that is actually, it can be shown mathematically. So I will show it at the, if time permits, when we discuss about the motors, that if the frequency increases, the size of the machine comes down. It is the design, So yeah.
Then why we increase the frequency given in India?
Why don't we increase?
Yes, sir. If we
very
make
good.
yes, continue, sir.
No, but if you can increase, then if you increase the frequency, the size will be small. But it will need a different technology. The cost of the equipment will rise. There are many things.
So maybe all the appliances are not equipments, right? Used to are not adapted like that.
No, somebody asked this question. Who asked this question in India?
The equipment size will decrease, so the price will also decrease.
No, I'm asking who asked this question. It is very good question. But,
Dhananjay Swami.
No, Dhananjay. So, okay, but we are on the land. Okay, so in the land you can put a bulky system, and you don't need to because as soon as to handle the high frequency, you need another technology. The cost of the equipment will rise. Okay, and if the cost of the equipment rises, Aam Aadmi will not be willing to pay. Okay, so the Aam Aadmi willing to pay for Aam Aadmi, you have to make equipments of an affordable price. Okay. So,
Sir,
but in the
why will the cost rise?
Why will the cost rise?
So the design will change.
Sir, the reason why
there will be a lot of design changes. There are a lot of other issues will be there. So for that reason, your air travel is costly. Okay, so you have to make a rocket. It will need a lot of money. But the advantage is it will come at a smaller size. You can pack the things without actually increasing the payload. You can build the aircraft without increasing the payload. Even in the land also, even for land applications, there are applications for 400 hertz. Okay, like in the land where it would be. All the military equipment. Suppose you are going to fight with the tank. A tank also needs power. Okay. A tank, to operate a tank, all of you have seen tanks? Maybe
Yes.
if you are
Yes,
near
sir.
military base or some video, so a tank also
Yes.
needs power. So now when you go to fight the enemy, to operate that tank, if you have to tow a bulky generator, then you are gone. Okay, so because what you have to actually carry, what? You have to actually carry is ammunition. When you are going to the war, you have to carry ammunition. So if you have to carry more and more ammunition rather than carrying a bulky generator with you. Okay, so their applications are also at 400 hertz. Okay, so that will actually reduce the size of the generator. Okay, so it can be mathematically shown. I will, if time permits. Of this syllabus is very, lot of things are there. So if small, I get a time, I can just one small mathematical analysis is there. That if the frequency increases in a small volume, you can get more power, which is required once you go for these applications for the army, for aircrafts, for rockets, even in the ship and everywhere. Now, the alternating current, voltage source is basically represented by this type of symbol. So long we were representing the symbol by the symbol of the battery or by putting a round sign with a plus minus. But since this is an AC source, this is the symbolic representation of an AC source. So an AC source, that is the VT, or if it is a sinusoidal source, the formula that I have written, Vt is equal to Vm sin omega t. So it will basically look like this. And you see, you have to be very careful that x-axis is basically omega t. Okay, the x-axis is omega t. So if it is the time axis, you know what to do, what are the changes there in this axis points. So what it shows is the voltage varies from plus Vm to minus Vm in a sinusoidal manner. Okay, it becomes maximum at pi by 2, minimum at minus at 3 pi by 2, and so on. So you can draw this. So this is the alternating voltage source, and just I've shown one waveform. Now, if V1 is equal to Vm sin omega t, now suppose I give you another source which is V2 equal to Vm sin omega t plus theta. Okay, so there is another source which is Vm equal to plus omega t plus theta. So how will it look like? So this is your Vm equal
So it will
to.
be shifted to horizontal.
So this one is Vm sin omega t.
Theta phase will be.
So if you see, so this is omega t. At omega t equal to 0, the value is 0. Now, if for V2, if you put omega t equal to minus theta, the value is 0. Okay, so it basically looks like this. So it is the same.
Shifted to the left.
Shifted to the left, because if you put omega t equal to minus theta, then the value of V2 is 0. So, but again, the nature is the same. Again, it will go on. Okay, so this is V2 equal to Vm sin omega t plus theta. Okay, both of them are sinusoidal voltage sources, but one of them is ahead of the other. Okay, the V2 is ahead of V1. Okay, so we will come to this. So this way you can have different types of voltage sources. Now by changing this theta, you can have several voltage sources, and again, obviously we have kept the Vm constant, the magnitude constant. But if you change the magnitude, you can have voltage sources differing in magnitude as well. Now Vm equal to Vm sin omega t, V1 equal to, and V2 is equal to Vm sin omega t plus theta. Okay, so this is basically the V1, and this is V2. Okay, so the next comes basically the concept of phasor. Okay, so phasor is basically a concept that will be required in AC. Okay, so concept of phasor means these voltages, okay, are basically changing with the value of V1 and V2 are basically changing with omega. Okay, so you can consider it to be suppose there is a vector of magnitude Vm which is rotating at an angular speed omega. Okay. So Vm, so starting from some reference. So starting from some reference, if this vector is rotating, okay, so that means, and in some counterclockwise direction. So this is the reference, and with respect to this reference, the vectors are rotating in the counterclockwise direction. The vectors are rotating in the counterclockwise direction. Okay, and suppose you have the eye placed here. So you are looking from the eye, and the vectors are rotating in this direction. So it is, if it is rotating at the angular speed omega, at omega t, it will cover certain angle. Okay, the vector of magnitude Vm after omega t will cover some angle. So Vm sin omega t will be what? Is basically the what?
Projection of the vector on the what, perpendicular to
In the y-axis.
on the y-axis.
Projection of vector on the y-axis, sir.
On the y-axis. Okay, so at rotating at omega, after time t, it will basically cover a distance omega t. So vector will be here, and this is basically Vm omega sin omega t. It is basically rotating at a angular speed omega, where omega is defined by 2 pi f and so on. So now with respect to this, what is Vm? V2 is Vm sin omega t plus theta. So what is the meaning of this? V2 is with respect to V1, where is it? It is theta angles ahead.
Ahead of theta.
Ahead.
It is theta angles ahead. Okay. But magnitude is same. But these magnitudes are the same. Okay. So this is basically V2. So what does this basically see? That if your eye is here and these vectors are rotating, which one will come first? Which one will the eye see first?
V2.
I2 will see first. So once these are rotating in this direction, first V2 will come. Then once V2 is crossed, then V1 will come. So the eye will see the V2 first. Okay, so this is, and geometrically, if you plot it, you basically get like this. So V2 will come first before V1. Okay, so this is, it is spelled out as that V2 leads V1. V2 is leading V1. Or alternately, you can also tell that V1 lags V2. Okay, someone is going ahead. When you are, all of you will come here and participate in different types of events and all, there are sprints, and also when there is a sprint or run, somebody is leading. So we can tell that Ram is leading Sham. But we can also tell that Sham is lagging Ram. So just like that. So this is the concept of leading and lag. So once there is an alternating source or alternating quantity, there will be a question of lead and lag, because both of them will have a separation. If V2 is also sin omega t, then they are together. They are going in parallel. But here is V2 is Vm sin omega t plus theta. That means V2 is theta angles ahead of V1. So obviously, to compare whether lead or lag, you have to convert it to the same trigonometrical quantity. You cannot compare a sine with a cos. Can you do? Compare a sine with a cos.
Yes, sir, by considering pi by 2.
Adding pi.
Yeah, but so that yeah, so that basically means that you have to convert to the same trigonometrical quantity. Okay, just directly you cannot compare. So once you have compared to the same trigonometrical quantity, you can. So that is basically the concept of phasor. Whenever there is an AC quantity or alternating electrical quantity, it can be voltage, it can be current. Okay. So they will be basically sinusoidal functions. They are basically sinusoidal functions of time. Obviously, time is there. And depending upon this theta, it will determine, obviously they have to be of the same frequency also. Omega equal to 2 pi f. The frequency has to same. You cannot draw the phasors of multiple different frequencies on the same diagram. So this is basically called phasor diagram. This will now gradually come. We cannot do in the phasor diagram with different frequencies. Their frequencies have to be the same. And once their frequencies are same, this theta will determine which one is ahead and which one is lagging. So we can tell that V1 leads V2 leads V1, or alternatively we can also tell that V1 lags V2, because the concept is coming from here, assuming that all the phasors are rotating in the counterclockwise direction, and there is a reference. All the measurements are done with respect to that reference. And if your eye is placed here, which one it will see first? The one which will see first is basically leading. So V2 leads V1. Or alternatively, you can tell V1 lags V2. Okay. So this is basically the concept of phasor, and these are going to come now because the electrical quantities, whether it is voltage, currents, they will be sinusoidal functions of time. So either it is a function of sine theta, the sine or cos. Okay. So the next thing is, suppose I give you V1 Vm cos 5t plus 10. Omega value I have given 5, and there is another V2 Vm sin 5t minus 30. So you see this 5t and 5t, they have to be the same because that is the omega t. Omega has to be the same. If they are different omegas, you cannot do in the same phasor diagram. So can you draw the phasor for this?
Yes, sir.
So you basically have the reference here.
Yes, sir.
Okay, so with respect to this reference, where will it be? Suppose we assume sine.
One leading.
See, one is given in cos and the other is given in sine. You have to convert them to the same type. Unless you cannot you convert them, you cannot draw the phasors. So suppose I assume
So V1
sine.
equal to Vm cos Vm sin 5t plus 100, and V2 equal to Vm sin 5t minus 30.
So let us assuming sine. So let us first do V2. So V2 is basically here.
Yes, sir.
That is with respect to the reference, it is at minus 30 degree.
Yes.
Okay. So now
Yes,
this,
sir.
somebody told, now this has to be converted to sine. So this V1 is equal to Vm sine how much?
5t plus 100.
5t plus
5t plus 100. So for all this trigonometry, you people are expert, you know. But it has to be done, you know, sine 5t plus 100. So first thing is you have to observe whether the frequency is the same. Frequencies were same, 5, that omega thing. And then they have to convert it to the same. So now you draw the phasor. So this will be located at an angle plus 100 degree. But the magnitude is same. This magnitude can be different, you know, for some cases if the magnitude is different, it is some other voltage source. But this frequency has to be the same because they are part of the same system. So where will it locate? It will be located somewhere like here. Okay?
Yes, sir.
Excuse me, sir.
Yes, sir.
Sir, is it necessary that the functions need to be sine only? Can we do it in cosine too?
You can do it cos also. Then you have to convert everything to cos.
But we follow the same procedure, no?
Yes,
Means
yes.
for phasor.
Sir,
Hmm.
so if the sign of any function like V2 is minus Vm, then we will convert this minus to plus and then compare, na?
How will you convert minus to plus?
Adding pi or subtracting pi.
Yeah, so that minus you have to absorb inside the trigonometric term and then see what happens.
Okay.
Okay.
But sir, we will compare all these two equations by considering positive sign. So we will take minus sign in by adding or subtracting pi. It is right,
You have
sir?
to do accordingly. Whatever changes needs to be done inside only. Yeah.
Okay, sir.
So in this also you can hear what is the total angle, 130 degrees. So V1 leads V2 by 130 degree. If it lags, you know what is the language. So V1 leads V2 by 130 degree. That means if the eye is here, so after V1 passes, then after 132 degree V2 will pass.
Can you show the previous slide once again?
Previous slide में क्या है? Huh? You're still into the previous slide. Yeah, any question?
Here, omega t. V1 should lie along the x-axis.
V1
should lie along the x-axis.
You can keep it anywhere. So if you make V1 lie in x-axis, then V2 will be just theta ahead. Okay. But since it is sine omega t for a particular t, it will be at
equal
omega.
to 0, it will be on x-axis.
Yeah, so I have shown it for some arbitrary t. Okay, to show that for a particular t, this will be at omega t, this will be at omega t plus theta. Okay.
Sir, in this question, V2. Sir, in this question, V2 should lead V1 because our eye will see first V2. Will see first V2 because we are rotating in counterclockwise direction. Then our eye will see first V2. Then V2 leads V1.
No, whichever it is, like if you still rotate further, first V1 will be seen.
Sir, we are rotating in counterclockwise direction. First V2 passes reference line, then our eye will see first V2.
Okay, so that it depends upon in what way you represent it, because see in this case V1 has already crossed this reference line. V1 has already crossed the reference line, and it is ahead of it because the vectors are rotating in this direction.
Okay, sir.
Now, if this is the situation, like if you have an RL circuit and it is fed by an alternating source of Vm cos omega t. So instead of sine omega t, I have just assumed cos omega t, but it is it can also be done for sine. So we have an RL circuit with Vm sine omega t, cos omega t as the voltage source. So obviously it will lead to a time varying current in it. It will lead to a time varying current in the circuit. Okay, so as soon as you apply a time varying voltage source, that will lead to a time varying current in the circuit. And ultimately we have to solve for the time varying current. So you know that it will basically lead to this type of a differential equation. The drop through R is Ri or RIC. Drop through L is L di dt, and which is equal to the voltage source. Okay. So this will, now we will have to solve this and let the solution be. I think all of you can solve it also. So since there is the input is sinusoidal, the response will also have a sinusoidal nature. So let the solution be something of this form, that IT, we are looking for IT is equal to I1 cos omega t plus I2 sin omega t. So let the solution be I1 cos omega t plus I2 sin omega t, where we are required to find the values of this I1 and I2. That will satisfy this differential equation. So to solve this differential equation, we also need to find out di dt. So just this assumed solution, if you find the di dt, it will basically
Sir,
lead
how
to...
did you assume one?
Which one?
Sir, this sample solution of I1 cos omega t plus I2 sin omega t?
No, we have assumed a solution, and let us see if we can get the solution, because the input is sinusoidal.
Okay, sir.
Okay,
But
so
sir,
if
how
you,
we did understand that the equation is sinusoidal, sir?
huh? Let us see if we can get the
Why
solution.
Sir, why did not you
VM
assume
cos omega t is
I1 cos
given. That
omega
is
t
why
plus
it
I2
is.
cos omega t?
Yeah, tell me.
Sir, why you assumed that IT should be I1 cos omega t plus I2 sin omega t? Why?
Because we have assumed, we have put, given, applied a sinusoidal input.
Voltage is
Okay.
sinusoidal. That is why.
Yeah, so let us assume.
The right term is sinusoidal only.
Yes. So the current will also have some sort of a sinusoidal nature. Okay, and let us see what is the form.
So
So if you
because
find,
we can, we by differentiating only a sinusoidal function, we can get
you can get
another
only the sinusoid.
sinusoidal function.
Yes.
That is why on the right hand side it's sinusoidal, so it must be a sinusoidal on the left hand side.
Yeah. So if you have to do this, if you substitute this in the original differential equation, you will get this. You know, this you can do on your own. And then you put, taking the cos and the sine terms together, if you put that, you bring out that Vm cos omega t on the left hand side. So, and if you keep these sine terms together, which will lead to minus L I1 omega plus R I2 sine omega t plus L I2 omega plus Ri Ri1. So this I1 and I2 have to be found out, minus Vm and this cos omega t equal to 0. So what is the inference from this? The right hand side is 0. So when can the left hand side become 0?
Coefficients of sin omega t and cos omega.
Coefficients of sin omega t and cos omega t to 0. Okay, so this equation is true for all values of t. Okay, so if for all values of t, for any value of t, there will be sin omega t, there will be some cos omega t value. But to ensure that for all values of t, this equation holds, the individual coefficients should be equal to 0. Your minus omega L I1, that is the first term, the coefficient of sin omega t should be equal to 0. Similarly, the coefficient of cos omega t, that is omega L I2 plus R I1 minus 2. Okay. So if you solve this, because what is the unknown?
I1 and I2.
I1 and I2, capital I1 and I2. So if you solve this, so simultaneous solution of I1 and I2, you will basically get this. I1 equal to V.
Excuse me, sir.
Yeah.
Sir, instead of taking I1, I2 and the two functions, can we just take I into sine omega t plus phi or I cos omega t plus phi?
That also you can try. That will basically lead to a sine and cos term. Basically, we are going to trying to find that phi. Eventually a phi will come.
Yes, sir. Sir,
Okay,
but that will be more simple, no? Than this, or
you check
this
out
is
if it is simple, that will be good.
okay, sir.
But basically, we have to take a combination of sine and cos and see whether
Sir, by making
whether both are there or only one of them is there. Yeah.
Sir, by assuming a solution and then making it, are we doing? Are we making components of the original current along the axis?
Components means?
Sir, we draw a graph like in phasor diagram. We make the original arrow representing the eye, and then there are two perpendiculars representing sin omega t and cos omega t. Are we
Yeah,
doing
yeah.
this?
So yes, current will also be a phasor. We are trying to find that.
Okay, sir.
Because it will current we have represented in terms of a sinusoidal term only. Okay, so if you solve this, so you get this I1 and I2. If you substitute this in the original equation, you basically get this. So substituting this I1, I2 in this equation, Okay. And this, just by little manipulation, we just took out root over r square plus omega square L square and Vm, which is there in the numerator, out. So what you are left with is, along with the cos term, r by root over r square plus omega square L square cos omega t plus omega L by root over r square plus omega square L square sin omega t. Okay.
Yes, sir.
So now you substitute this r by root over this as cos theta, and so it is cos theta cos omega t plus sin theta sin omega t. So this is equal to what? Cos omega t
minus theta.
Minus theta.
Cos omega t minus theta. So all your trigonometry, whatever has to be correctly applied. So your cos theta is nothing but we have substituted this, that is root over r by root over r square plus omega square L square, and sin theta is omega L by root over of r square by plus omega square L square. So this will basically lead to, so this was the circuit, and Vm by root over r square plus omega square L square cos omega t minus theta. So your theta is basically tan inverse of omega L by r. You find out from that expression, you had the sin theta and cos theta. So theta is nothing but tan inverse omega L by r. That means if you are given a circuit and the circuit values are r and L, then this theta, by applying Vm cos omega t, the value of the current will be also be sinusoidal, but cos omega t minus theta will be there. But theta is tan inverse omega L by r. Omega will be coming from this source, and the magnitude of the current changes to Vm by root over r square plus omega square L square. Okay.
Yes, sir.
So this I is equal to basically Vm by root over this. So this becomes Im cos omega t minus theta. You see, by applying a voltage Vt equal to Vm cos omega t, we are getting a current It, which is Im cos omega t minus theta. Okay, Im cos omega t minus theta. Okay. So you see, in electrical quantities, basically you need to draw a phasor. So if this is your reference, and the vectors are assumed to be rotating in the counterclockwise direction with an angular speed omega, your voltage phasor is basically here. If you put the voltage phasor along the reference, where will be the current phasor?
So just below
at an angle of minus. Okay, so the current phasor will be at an angle of minus theta, and it will have a different magnitude. Okay, because magnitude for voltage was Vm, for voltage of current is something else, because it is Vm by root over r square plus omega square L square. Yeah.
So in 10 plus 2 level, we learned that the current and voltage have a phase difference of pi by 2 for RL and RC in AC. So why did
I by
was always having a difference of phase difference of pi by 2? Why?
Okay, we'll come to that. We'll come to that. What is your name?
Pranay Datta.
Pranay. You are computer science.
So I'm Tanmay Datta, and I'm mechanical engineering.
Mechanical engineer. Oh, you have a lot of electrical interest. Okay, so we will come to that pi by 2 and also this. But at least there will be some angle now, theta. And theta is given by this. If you have a finite value of L and a finite value of R, it is tan inverse omega L by R. You know what is tan inverse and all. How to calculate
Can we directly use It is equal to Im cos omega t minus theta or Im sin omega t minus theta in example?
Yeah, you can directly use. That is the purpose. If it is Vm cos omega t, the current is It is equal to Im cos omega t minus theta. where this is, but the Im will be related to this. Vm by root over r square plus omega square L square, and theta is given by this. Okay,
we
so
don't have to do the previous calculation.
no. That is part of that is how this is the final expression. If you are given this Vt, this you are getting the It, and I will just discuss with the what Pranay told shortly, because I will come to that. So here basically you see that It lags Vt by theta. The way we have represented It lags Vt by theta, or because if the vectors are rotating, you will first see Vt because we have placed Vt along the reference, and then you will see It. So It lags Vt by theta, or you by any other thing you can also even tell It leads Vt by 360 minus theta, but it is telling the same thing. Okay. So the lead lag thing is that relative concept. So you have to consider somebody ahead and then tell the other one. So because
Sir,
Vt, yeah.
Sir, actually we have a physics test in 5 minutes, I think.
Okay, maybe in another 1 minute I will finish. But this is actually the last slide of today's lecture. But just a few things, which is just from the derivation. So if omega equal to 0, so it is omega equal to 0. So this is basically DC, a constant source. With omega equal to 0, it basically implies DC. But if your L equal to 0, suppose L is equal to 0, it is basically a purely resistive circuit. If L equal to 0, it is a purely resistive circuit. So if your L equal to 0, what happens to theta?
Zero.
Theta 0. So in that case, Vt and It align. Okay. Phasor diagram will look like this. But if suppose your R is equal to 0, R equals, what about the theta?
Then pi by 2.
Theta equal to pi by 2.
90 degrees. Pi by.
So that means Vt and It are perpendicular to each other.
Yes, sir.
Okay, as Pranay told, it was written in your 12 books. So in that case, what will be the phasor diagram? Tanmay. Okay, so in that case, what will
voltage and current through inductor only.
Oh, so it was pure inductor. So that is the thing. I have done R equal to 0, so pure inductor.
Yes, I forgot.
So
that part
this will be your. So if you put the voltage phasor,
Hello, sir.
Sir, you are not audible.
Sir, you are not audible, sir.
okay, am I audible now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir, you are audible, sir.
So that was my last slide, that I wanted to discuss today. Okay, for the different cases, and I will stop today. But before that, I will give a list of references, the list of books that you can use for practicing on the topic so far. But other books are also there. And
Sir, once the
Is
previous
the
slide.
preferred book over all this?
the more you practice, it is good,
Sir,
Thank
so
you.
actually I am unable to find any one of the books, sir.
No, you'll have to eventually find, Then otherwise you have the online NPTEL lectures also. So this is actually the topics of the module 1, of the syllabus, which I will actually send this PPT to all of you.
Sir, do we have to solve the only problems or read its theory also?
Obviously, theory is required. There can be some problems related to theory also.
So will you send the
So
slides
with the
today?
theory,
Yeah, now I will send the slides because I
Okay.
plan to